Hi. Okay, so this is Lab 3 Black Hole, and this is for Physics 2211 spring semester, and my name is Rahul Chawla. So going into the introduction for the lab. So basically for this lab, we are tasked for predicting the mass of an unknown object, which in this case is a black hole. We'll be using different properties about this object, such as changes in velocity, momentum, and force. So some of the properties that we will use to calculate this is the law of universal gravitation, which I've written out here. Fg equals g m1 m2 over r radius squared. Then we will also have to take into consideration the parallel and perpendicular components of momentum. And I've written the equations here that deal with changes in momentum and how they relate to each other. And using all of this data, we'll be able to estimate the mass of the object with the given data. And now I will go into the code of the model that was given to us and explain how this will be used to determine the mass of the black hole. So obviously I use a starter code, and the first thing I did is I changed the seed to my email, and then I go through the calculations and go to the part where we're supposed to alter, and mass of the star, edit this line. So this is basically the mass that was given to us in the Canvas description, and the time interval between the imported data points. So this is 86,400 seconds, which is basically the amount of seconds that takes place in one 24-hour day, which was also um, described to us in the Canvas description. And then when we go into the calculation loop, I compute the initial and final momentum vectors by basically performing the basic momentum equation, which is velocity times mass. And I do that for both the initial and the final values. Using that, I'm able to calculate the changes in velocity and momentum from the values that we just solved for. And then I plug this into the equation to solve for delta dp dt. So change in momentum over time, so change in momentum and change over time. And then using Newton's second law, I can calculate the net force with this. And then I also calculate dp dt parallel. And I also use Newton's second law to calculate F net par, dp dt perpendicular, F net perpendicular, and then calculate the mass of the black hole, basically by using the equation that I described earlier on the slides. And then using this, I'm able to basically draw the arrows that represents all the forces, and then the scale, I made it very small just to make it more accurate. And then we have the different vectors for each different position and axis. And then I save the results in a list and determine the um, average mass of the black hole by basically going through all the trials and determining the average point. So now I'll go ahead and run the program. And okay, as you can see, it's running, and eventually it will come to a stop. And then through this, we have all the print lines of all the forces that I discussed earlier. And then here we come to the conclusion that the average mass of the black hole is 1.0026 times 10 to the 34 kilograms. And that is basically what the model has predicted, and that is what we will go for the answer. And then when we come back to our presentation, basically, so that is the data, and then clearly we saw the model with the arrows going through and how it was visualized to show the eventual mass. And so some of the questions that we were asked to answer for this lab: how are net force and its parallel perpendicular components different from the rate of change in momentum? So basically, quantitatively, these values are essentially proportional. Are equivalent, but conceptually, there's a difference between F net is simply the sum of the total push and pulls on an object, and momentum actually represents a physical change in the object's motion, because it's the velocity times the mass. And and then another question we were asked to answer was, would this model work for other black holes? And I would say yes, this code would work for other black holes because the calculations are based on updated mass, and the model is dependent on changes in velocity, which we will know for all black holes because we calculate it through the calculation loop. Yeah, and that is basically my presentation on Lab 3 Black Hole. Thank you for watching.